Hello and welcome to Lunar 24. In these tutorials, we are looking at solving quadratic equations by the quadratic formula. To use the quadratic formula, the equation must be in the general form ax squared plus bx plus c equals 0. To begin, the equation should be in the general form. If it's not in the general form, rearrange it, where a, b, and c are known as constants. We now use a, b, and c in the quadratic formula, and remember to write the equation correctly as well as the formula. Okay? So the quadratic formula states that x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula we are going to be using in solving the quadratics. For example, in the equations shown by the side, 2x squared plus x minus 3 equals 0, the values of a, b, and c are respectively a equals 2, b equals 1, and c equals negative 3. Equally, for negative x squared plus 4x minus 4 equals 0, the values of a, b, and c are negative 1, 4, and negative 4. Now, let us take an example. So, example 1 reads x squared minus 4x plus 3 equals 0. To solve this by the quadratic formula. So, the first thing to do is to state the values of a, b, and c. Please speak as you follow the video. So, the value of a here is 1, b is negative 4, and c equals plus 3 or just 3. So the next thing now is to state the quadratic formula. So x equals negative b plus minus the square root of b squared minus 4ac, all that over 2a. We now substitute these values into this equation as follows. So this will be equal to, the negative sign is already here, okay? So I'm just going to add another negative. So our b here is negative 4. So we have negative 4 plus minus the square root of our b there is negative 4, negative 4 squared minus 4 times a, which is 1, times c, which is 3. All that on 2 times a. 2 times, that's 2 times 1. Now simplify the values. So this will be equal to, these two negative 4's together, not separated by any number, is going to give us plus 4, plus minus the square root of negative 4 squared is 16, minus 4 times 1 times 3 is 12, all that on 2. We simplify what we have inside the root sign. This is going to give us plus 4, plus or minus the square root of 4, all that on 2. From this point, the square root of 4, as you already know, is 2. So here we are going to have 4 plus minus 2, all that on what? All that on 2. Therefore, the values of x are as follows. Either x is equal to, we take the positive sign, 4 plus 2 on 2, or x equals 4 minus 2 on 2, giving us the final values, x equals 3 and x equals 1. So make sure, if you want to really gain and keep these skills, then you actually need to make sure that you solve as much as possible. So our values here are x equals 3 and x equals 1. Let's take the second example. So example 2 reads 2x squared plus x minus 3 equals 0. So the values of a, b, and c are respectively 2, 1, and negative 3. Those are the values of a, b, and c. Now let's state the formula. So the formula states x equals negative b plus or minus the square root of b squared minus 4ac, all that on what? On 2a. We now substitute the values in this formula. This is going to give us negative 1, b is 1, plus or minus the square root of b squared, b is 1, so 1 squared, minus 4 times a is 2, times c is negative 3. I always like that you should write these products in these brackets as you can see them. All that on 2 times a, all that on 2 times a, which is 2 times 2. So simplifying is going to give us negative 1 plus or minus the square root of 1 minus 4 times 2 times minus 3. That's going to give us plus what? Plus 24. Okay, so that gives us plus 24. All that on 4. So 1 plus 24 is 25, resulting in negative 1 plus or minus the square root of 25, all that on 4. The square root of 25 is 5. So we have negative 1 plus or minus 5 on 4. Therefore, the values of x are x equals negative 1 plus 5 on 4, or x equals negative 1 minus 5 on 4. Finally giving us x equals 1 and x equals negative 3 on 2. So you can look at the video, you can solve and solve again. Let's look at the next example, example number 3. So with our third example, we have the equation as follows. 4x squared minus 4x plus 1 equals 0. The values of a, b, and c are respectively 4, negative 4, and plus 1. Okay? We now state the formula. Quadratic formula states x equals negative b plus or minus the square root of b squared minus 4ac, all that on 2a. Substituting these values gives us negative 4 plus or minus the square root of negative 4 all squared minus 4 times a, which is 4, times c, which is 1. All that on 2 times a, which is 4. Okay? So simplifying will give us a 4 plus or minus the square root of 16. Okay? 4 squared, negative 4 squared is 16, minus 4 times 1 is 16 as well. So the result is 16 minus 16, all that on 8. So this will be equal to 4 plus or minus the square root of 0, all this on 8. Therefore, the roots will be 4 plus 0 on 8, or 4 minus 0 on 8. So the result will be x equals a half and x equals a half. In this case, where you have the roots being repeated, it is because the expression in the root sign b squared minus 4ac is having a value of 0, and whenever that expression has the value of 0, then the result is we have repeated roots or equal roots. In this case, we say that the discriminant is equal to 0. The term b squared minus 4ac is known as the discriminant, and whenever that value is 0, then we have repeated or equal or identical roots. Take note. All right, let's look at some remarks. I think I just mentioned one. Let's look at some remarks. So in the quadratic x squared minus 3x equals 0, in this particular one, there is no c term, okay? So c is equal to 0. And in the quadratic x squared minus 4 equals 0, the middle term is not there. That's the term in x. Therefore, our b is equal to 0. This type is also called the difference of two squares, because x squared is a square and 4 is a square. Even if it was 3 that was there, we still call it the difference of two squares, because the square root of 3 is root 3. Alright, now for x squared plus 4 equals 0, this one has no real solution. It has a solution, but the solution is not a real number. It's an imaginary or complex number. And this is a grade 11 and grade 12 math. So we say it has complex roots. In all quadratics, the value of a cannot be equal to 0, because whenever a equals 0, it becomes a simple linear equation. The discriminant d equally, as I said, d was equal to b squared minus 4ac. It's called the discriminant because it tells us the nature of the roots. If b squared minus 4ac is negative, you're going to have complex roots. If it is equal to 0, you have repeated roots. And if it is greater than 0, you have a non-identical root, as we are going to see. So it tells us the nature of the roots. So let d be equal to b squared minus 4ac be the discriminant. If d is greater than 0, we are going to have two real roots which are distinct or unequal. If d equals 0, we are equally going to have two real roots which are equal or repeated. However, if d is less than 0, then we are going to have imaginary or complex roots. So there is no solution in the set of real numbers. Okay? Thank you guys so much for watching, and follow our other videos. This video is under Algebra 1. We equally have videos in calculus, geometry, AP statistics, programming, and much more. Please, you can visit the website www.lunarlearn24.com for quizzes, tutorials, classroom, and much more. Thank you so much, and don't forget to subscribe. Thank you so much. Bye bye.